Hi folks, we're going to take a look at number 5 from the December 1st worksheet. Okay, so you've got a spring that's pulled 32 centimeters from the wall and is let go. Okay, so let's see what this situation looks like. So you've got some spring, okay, that's being pulled, okay, to 32 centimeters away from the wall. So that's going to be its maximum extension. Okay, and then it's let go, and we're told that the minimum extension is 8 centimeters from the wall. Okay, now they're asking us to determine the times at which the spring is 12 centimeters from the wall within the first 10 seconds. Okay, so first thing I realize is that if I'm starting at 32 centimeters where I've extended the spring, that's my maximum. Knowing that I'm starting at my maximum, I should be thinking of using cosine. Okay, so let's just make a list of our main characteristics, because what we're going to do is we're going to create a model and then use that to solve our problem. Okay, so we have a max which is equal to 32, and we have a min which is equal to 8. So from here we can determine our A and C values for our model. Okay, so the amplitude is half the distance, so 32 minus 8 divided by 2, so that's going to be 24, that's going to be 12, and then our C value, the equation of our axis, is going to be given by the average of these two numbers, so 32 plus 8 divided by 2, which is 40 divided by 2, 20. Okay. Now the other thing we need, and we are given that the period is equal to 2 seconds, so from there we can get our K value, our horizontal stretch, which is just going to be 2 pi divided by, in this case here, the period 2, so our K value is going to be equal to pi. But as we said, since we're starting from the maximum and there's nothing that says we have to use sine, I'm going to use cosine, and so we won't need a phase shift. Okay, so here the parent function that I'm going to be working with is cos x. Okay, so from this information we can create a model for this scenario. So we've got that y is equal to 12 times cosine of pi x and then plus 20. Okay, where y is the distance from the wall and x is the time in seconds. Okay, so now what they want to know is when is this distance 12. So I'm just going to replace my y value by 12, and now we're going to go ahead and solve this equation. Okay, so first thing we do is, since we can do it here, is isolate the trigonometric ratio. So cos of pi x is equal to, well, 12 minus 20 is equal to negative 8, and divided by 12, so negative 8 over 12 is negative 2/3. Okay, now since that's not a nice fraction, I'm going to leave it as 2/3. I'll wait to use my calculator to find some approximations. Okay, so we need to calculate all the possible answers here from 0 to 10. Okay, so let's start by calculating the first two answers. So here I've got cosine is equal to some negative number. So I know that when I use inverse cosine, it's going to give me some answer between pi over 2 and pi. Okay, and I know that I'm going to have another answer which will be valid between pi and 3 pi over 2. So if this here is theta, that there is going to be, okay, whoops, there we go, to there is going to be 2 pi minus theta. Okay, so that's going to be 2 pi minus theta. Okay, so let's get our calculator out. Okay, so here we've got inverse cosine of negative 2 divided by 3. Okay, and that gives us 2.3. Okay, so that means that pi theta, pi x, sorry about that, can be equal to 2.3. So that would be this first answer here. But then I also know that pi x can be equal to 2 pi, which I'll estimate as 6.28 minus 2.3. Okay, so here, what does that give us? Let's not take any chances here. 6.28 minus 2.3 gives us 3.98. Okay, so here x itself is going to be equal to 2.3 divided by pi. Okay, so 2.3 divided by pi gives me 0.73. So that'll be 0.73 seconds. Okay, and then from here we get 3.98 divided by pi equals 1.27, we'll say. Okay. So now, these are our first two answers. Okay. However, they want answers all the way up to 10 seconds. Okay. So, let's think about how we can do this here. Is we know that the period for this spring goes back and forth every 2 seconds. So if it's going to be at a distance of 12 centimeters at 0.73 seconds, I can add 2 seconds to that to get my next answer from this one here. So 2.73 seconds. Because remember, this thing repeats every 2 seconds. Okay, so I'm still not at 10. Let me add another 2 seconds. 4.73 seconds. Still not there. So I can have 6.73 seconds. Or I can have 8.73 seconds. But this is when I realize that if I add another period, another 2 seconds, I would be at 10.73, and I would be beyond. I would be beyond the domain of values that I'm interested in. Okay, so that's as far as I can go on this side, and here I can do the same thing. Okay, at 1.27 seconds, but I know it repeats every 2 seconds, so at 3.27 seconds, and 5.27 seconds, and 7.27 seconds, and 9.27 seconds. But if I add another period, I will have gone beyond the domain of values that I'm interested in. Okay, so notice how I solved this one here. I first use my knowledge of the Cartesian plane to help me determine the two values at which cosine would be equal to -2/3. But then I use the period of the situation itself to determine when I would get repetition of answers. Okay, and in this case here, I know that this repeats itself every 2 seconds. So once I had one answer, I just had to add multiples of 2 seconds to get other possible answers. Okay, that's it for this one.